is the fourth part of the series on functions. In this video, we'll be looking at the various information a quadratic function can give us, different ways to represent quadratic functions, and questions on this topic. We'll start with the various information we need to know about in a quadratic function. Those are x and y intercepts, coordinates of the vertex, if the parabola is concave up or down, and domain and range. These are the three different forms a quadratic function can be present in: the standard form, the factored form, and the vertex form. To find these four information, different methods need to be used in the different forms. So we'll be looking at that in this video. We will start with the standard form. A standard form is written like this: f of x equals ax squared plus bx plus c. When a quadratic function is in the standard form, we can easily identify if the parabola is concave up or concave down by just looking at the sign of the value a. If the a is positive, then the parabola is going to be concave up, and if the value of a is negative, the parabola is going to be concave down. Now let's look at an example. F of x equals 2x squared minus 6x plus 2. In this case, the value of a is positive 2, so the parabola is going to be concave up. Now, one more thing that we can easily find in standard form is the y-intercept. We know that the a value is going to tell us concave up or down, and if the constant c value can tell us what is the y-intercept. The c value is the y-intercept itself. So these are two values that we can just look at a quadratic function in the standard form, and we can understand these values. Now let's move on to the x coordinate of the vertex. So first vertex, we're going to first find the x coordinate. X coordinate. To find the x coordinate, we have to use the formula minus b by 2a. We just need to substitute in the values. So minus, a b is minus 6. So we're going to put minus 6 by 2a. The minus minus will cancel out. So it will become 6 by 2. A. So 2a is 4. So 6 by 4. Or you can write it in the decimals as 1.5. Let's find the y coordinate of the vertex. To find the y coordinate of the vertex, we have to give the input of the function as 1.5, which is x coordinate of the vertex, to find what y value coordinates to this value. So f of x equals 2 into 1.5 squared minus 6x minus 6 into 1.5 plus 2. If you simplify this, you're going to get the value as minus 2.5. That will be for f of 1.5. So your vertex is 1.5 comma minus 2.5. That's done. And we know the... Now let's move on to the x-intercept. We know how to find the y-intercept. We're gonna go to the x-intercept now. To find the value of the x-intercept, all we have to do is to equate this equation to 0, this function to 0. That's basically solving quadratic equations, and we looked at how to do this in one of the videos. If you solve this, you'll get two possible x values, and those are 2.62 and 0.38, and those are going to be our X intercepts. Now at last what we have to do is find the domain and range. We know in all cases, in all quadratic functions, the domain is X belongs to R. Now when it comes to the range, it's simple, we discussed it in the last video too. We know that the parabola is concave up, and we know the vertex, the y-coordinate of the vertex is minus 2.5. So we'll have a range as y greater than or equal to minus 2.5. Because minus 2.5 is the minimum value we can have. As this is over here and there can be no, we can't have any y values below this, only above this. So now we have the domain and range too. Let us take a look at another example. The question is f of x equals x squared minus 6x plus 8. Now we can just say the 8 is a y-intercept, and the coefficient of x squared over here is 1. 1x squared or x squared is the same thing. So we can take the coefficient as 1, it's positive. So we can say this function is concave up. The parabola is going to be concave up. We know this, so we can already jump to the domain and range. The value of the domain is going to be x belongs to R, and the value of the range. To find the range, we have to wait because we don't know the y-coordinate of the vertex yet. So let's go to the vertex. We need to find the x-coordinate of the vertex first. For that we have to use the formula minus b by 2a. Minus b by 2a. So that will be minus 6 by 2. 1 into 2 is 2. So that will be x minus and minus will cancel out. 6 by 2 is 3. So vertex we have 3 comma something. Let's find out what that something is. So we have to give the input of the function as the x coordinate of the vertex. So we're going to have f of 3 equals 3 squared minus 6 into 3 plus 8. So that will be 9 minus 18 plus 8. That will be minus 9 plus 8, so minus 1. So that's minus 1. We are done. Now let's find the x-intercept. Actually, let's finish with the range, since we know the y-coordinate of the vertex. So our range over here will be y greater than or equal to minus 1. Simple. Concave up, minus 1. So greater than that, equal to or greater than that. Now let's move on to finding the x-intercept, which is just to solve the equation, equate it to 0. And we have to solve it. If you solve this, you're going to get x equals to 2 and x equals to 4. These are the two possible values we can get, and those are your x-intercepts. So we are done. It's fairly simple, this method. When it's in standard form, we can find all the information easily. Now for your practice, I'm going to give you some questions. You can take this down, do it later. I'm going to give the answer keys to these questions in the description below. These are three questions which you can try solving on your own. Let's move on to the second form, and that is the factored form. Let's start with the question in this form. F of x equals x minus 4 and x plus 8. The factored form is just basically you solving the function, or you factoring the function, and then you get this. Instead of keeping it in the standard form, you have gone a little more closer to solving it. So to find the y-intercept over here, now first let's start finding the x-intercept. So let's just say x minus 4, x plus 8 equal to 0, because we have to equate it to 0. It doesn't matter standard form, factored form. Everywhere, only when it's equated to 0, you can get the x-intercept, because it doesn't matter what form it is in. Coordinate geometry is coordinate geometry. The x-intercept will be at y equal to 0. So you can have two possible values. Those are x equals 4 and x equals minus 8. Right? Yeah. To find the y-intercept, we need to make the input of the function 0. So basically, we need to do f of 0 equals 0 minus 4, 0 plus 8. You might ask me, why 0? 0 because y-intercept is basically when the parabola goes through this point. Suppose you have the parabola like this. When does it go through this point? At this point, it's probably going to be something like, let's just say 0.35. The x value is always 0 on the y-axis. So the y-intercept will have the x value as 0. So we want to find what is the y value when x value is 0. So f of 0 equals minus 4 into 8. That's going to give us minus 32. Minus 32 f of 0. Now we have both the x and the y-intercepts. Let's move on to the vertex. To find the x-coordinate of the vertex, we have to add the two x-intercepts and divide it by 2. Let me show you what I mean. 4 plus minus 8 divided by 2. Now you might ask me, why does this work, or why do I have to do this? It's because we discussed this earlier. A parabola from the line of symmetry moves in the same pattern, both the sides. If this moves like this side will also move like that. So at one point, if there is a line, don't you think the um, the line of symmetry is in the middle of these 2 points, because they grow in the same pattern? So when we want to take the x coordinate of the vertex, we just need to take the two x intercepts, add them up and divide it by 2 to find the value that's in the middle. And that's what we are doing over here. So 4 minus 8. 4 minus 8 divided by 2. That's minus 4 divided by 2. That's going to be minus 2. So we're going to say minus 2 comma something that we don't know yet. So let's find out that value. To find the y coordinate of the vertex, we have to simply give the input as the x coordinate of the x coordinate. So just like the previous one, in the standard form, similar way, we know that the x coordinate of the vertex is minus 2. So we will say minus 2 equals minus 2 minus 4 minus 2 plus 8, right? So when we do that, we will get f of minus 2 as minus 6 into 6. So that's going to give us minus 36. So we can fill this in as minus 36. Minus 36. Now we found out the x and y intercepts, the vertex. Now we have the domain range and concave up or concave down. Before going to the domain range, let's find out if this is concave up or concave down. In factored form, all we have to do is multiply these values to find if it's concave up or concave down. Because when we have suppose 2x squared plus 2x plus 2 or something, factored form is just a factored form of it. So when we expand this, we are going to get it in the standard form. So if we all we have to do over here is multiply x with x. That's going to give us x squared. And both of them are positive. So the coefficient will be 1. Since the value of a is 1, the parabola is going to be concave up. Suppose if you had a minus 2x or something else over here, it would have been concave down. So over here a parabola has concave up. We can get to finding the domain and range. The domain is going to be x belongs to R as usual, nothing different. When we get to the range, y coordinate of the vertex minus 36, a concave up parabola, self-explanatory, minus 36. This is the minimum point, so equal to or greater than this since we have a concave up parabola. We found out all the 4 information, so let's get to solving another question in the factored form. The question is f of x equals x minus 5 x plus 5. So we'll start with the x intercepts because that's the easiest thing to do over here, since they're already given as a question that's almost solved. So we'll have x equals 5 on one side and then x equals minus 5 on the other side. Simple. Done. X 5 and minus 5. Now we'll go to the y-intercept. To find the y-intercept, we need to make the input 0. So f of 0, that will be 0 minus 5 and then 0 plus 5. So minus 5 into 5, and that's going to give us minus 25. That is our y-intercept. Y-inter, and then we have our x-intercept right here. Done. Now we'll move on to the vertex. It's very crucial to find the x and y intercepts first, because that's what is going to help us go find the vertex, right? Because we need to know the intercepts, add them up, divide by 2, all of that. So when we move on to the vertex, to find the x coordinate of the vertex, x coordinate we will do 5 plus minus 5 divided by 2. 5 minus 5 0, 0 divided by 2 is 0. Our x coordinate is 0. Because apparently the parabola, the line of symmetry lies on the x-axis, the y-axis. So on the y-axis the x value is 0, right? So yeah. Now when it comes to a y coordinate, we don't have to do anything. We can just say it's minus 5 because this line is on the parabola, is on the y-axis. So the parabola is gonna go up like this. Considering this is a concave up parabola, we can just prove that right now. X into x squared, positive coefficients of concave up parabola. It's going like this. It's not gonna go through the um, y-axis ever again. It's gonna continue getting wider. So when in cases where the x-coordinate of the vertex is 0, the y-coordinate is just gonna be a y-intercept. That is minus 25. So our v is 0 comma minus 25. And we're almost done. Let's go on to the domain and range. We know it's concave up, we just discussed it, so we can jump to the domain and range. Let's write the domain. At this point, we don't even have to write it. We already know what's the domain. X belongs to R. Yes. And then we have to come to the range. So vertex minus 25 minimum, concave up parabola. So y greater than or equal to minus 25. We did it. Minus 25. We just explored the two of the methods. Now I'll give you two questions that you can practice on your own, and the solutions for this will be in the description again. So for your practice, you have f of x equals x minus 1 x minus 5. And then you have another question, f of x equals x plus 1 x minus 3 by 2. It's simple, nothing hard. Now let's move on to the last form, and that is the vertex form. When it comes to the vertex form, let's take a question first. F of x equals 5 x minus 4 squared plus 17. Now actually let's do another question first and then come back to this. A much easier one. It's f of x equals x minus 3 squared minus 4. Now this form is called vertex form because you don't have to do anything to find the vertex. The vertex is already given in your question. The constant that is being added or subtracted is your y coordinate of the vertex. So minus 4. And to find the x coordinate of the vertex, you take whatever's in the bracket. That's x minus 3. Equate it to 0. X minus 3 equals 0. Find x. 3. 3 comma minus 4. Done. We did it so easily, right? That's why it's so easy. We have our x coordinate of the vertex 3 comma minus 4. Yeah, done. Now let's go on to the x intercepts. That is again equated to 0. X minus 3 squared minus 4 equal to 0. So x minus 3 squared equals 4. X minus 3 equals, never mind. We know what is square root 4, that is 2. So we'll have our x-intercepts as plus minus 2. So x equals 2 plus 3, 5. And then x equals minus 2 minus 3. That is minus 5. Right? Yeah, and then minus 2 plus 3. That is 1 actually. So we have 5 and 1. Those are our x-intercepts. Now let's go to the y-intercept. That is again, we have to do it the same way. F of 0 equals 0 minus 3 squared minus 4. Simple. 0 minus 3 minus 3 squared minus 4. That is 9 minus 4. And what will that give us? 5. F of 0 is 5. So we have the x vertex, x intercepts, y intercept. Now we have, what do we have left? Concave up, concave down, domain range. Is this concave up or is this concave down? And even in this form, it's really easy. And normally in the vertex form, we have a value over here because it's, over here it's factored. Over here, that the question, they haven't given us any value because it doesn't make a difference if we have one outside or not, but that is a one. So we need to look at this value, if it is positive or negative. If it's positive, concave up. If it's negative, concave down. And we know one is positive, so concave up. That is done. Now we need to find the domain and the range. Our domain, as usual, x belongs to our range. Now concave up, we know that vertex y coordinate minus 4, y greater than or equal to minus 4. That is done. Now let's take a look at another example. This was the question that I gave you in the beginning. Now the vertex. We have 17. So 17. Solve for x minus 4 equal to 0. So what will x be? 4. So we have 4 comma 17. Now is this concave up or down? This is concave up. I told you we have to look at this value. And it's positive, which means it's concave up. Concave up. So now let's move on to the x-intercepts. Over here, you don't even have to start solving it to find out the x-intercepts. Or you don't even want to find the x-intercepts. I'll tell you why. I told you this parabola, this function is going to give a concave up parabola and our vertex is 4 comma 17. So that's a minimum point. Suppose this is 4 and this is 17. So a parabola is going to start right here. Now where are we going to have our x-intercepts? The x-line is over here, the x-axis, and the parabola is like all the way up here. We won't have an x-intercept over here, no x-intercepts. But what will happen when we start solving it? You will get imaginary values. It basically means you'll get something like minus 4 square root or something. Square root of any negative number is going to give you imaginary values, which means it doesn't belong to the real number set. They're not real numbers. You don't have those values. so you don't have the x-intercepts. Now the y-intercept, we just have to solve for 0 because in the y-axis x value is 0. So phi 0 minus 4 squared plus 17, that will be phi minus 4 squared plus 17, that is 5 into 16 plus 17, that will give us 80 plus 17, and that is 97. Now we have the vertex, x coordinate, vertex x intercept, y intercept, and now we have to go to domain and range. We know it's concave up to, so that's all we have left. Domain x belongs to R, range, oh god, we have the range we know that the y coordinate is the vertex 17 and it's a concave up parabola, so we are going to have y greater than or equal to 17. Done. This is all there is for the vertex form. For practice, I'll give you 2 questions. Practice, practice, practice. The first question is f of x equals 1.8 x plus 2.4 squared plus 2.4, and then you have the second question, f of x equals 3x plus 11 squared minus 2. This is all for this video. Thank you so much for watching. I'll put the answers for all the extra questions I gave in the description below. Subscribe to our channel, like the video, and comment down your thoughts and doubts.